entire future depends on this one shiny metal. Solar industry alone consumes somewhere between 15 to 20% of the entire global silver supply. Has the highest electrical conductivity of any element out there. India, a huge player in solar. Today, let's dig into something that's right at the heart of our clean energy future, the real and, rising price of solar power. You know, we all think of solar as our golden ticket to a green future. But what if I told you that entire future depends on this one shiny metal? It's a huge paradox, so let's unpack why silver, a classic symbol of wealth, might just be one of the biggest hurdles in our race to go green. So what's the big deal? Well, over the last decade, silver prices shot up by over 750%. And no, that's not a typo. This isn't just about your jewelry getting more expensive. This kind of surge has massive consequences for the global economy and for our climate goals. Okay, so let's dive into why that price exploded. To get it, you have to see silver for what it really is, an industrial metal pretty much in disguise. Its true value goes way, way beyond just looking pretty. Now, this is where it gets really interesting. We tend to think of gold and silver as basically the same thing, right? Safe places to park your money when things get weird. But silver has this secret double life. It's not just a store of value. It is an absolutely critical industrial workhorse. And that dual demand is what makes its market so wild and complicated. And this chart lays it all out. You can see right where all that industrial demand comes from. Of course, you've got your electronics, your medical stuff, but look at those two huge growing slices, solar energy and electric vehicles. The very technologies that we're counting on to save the planet are absolutely hungry for silver. So let's zoom in on the biggest driver here, what I'm calling solar's silver addiction. Because that's really what it is. It's the hidden and increasingly expensive ingredient that's powering this whole clean energy revolution. Just how addicted are we talking? Well, get this. The solar industry alone consumes somewhere between 15 to 20% of the entire global silver supply. Just let that sink in for a second. A single industry is gobbling up a fifth of the world's demand for this precious metal. So where does all that silver actually go? Well, it's used to make this stuff called silver paste. It's basically a special conductive ink that gets printed onto solar cells. You know those thin little lines you see on a panel? That's it. They act like tiny superhighways, grabbing all the electricity the cell makes and sending it on its way. And why silver? I mean, why not something else? It's simple, really. It has the highest electrical conductivity of any element out there, period. That property is absolutely crucial for getting the most energy out of a solar panel and maximizing its power. Without silver, today's super-efficient solar cells just wouldn't work. Okay, so demand is through the roof. The obvious question is, why don't we just mine more of it? Well, this is where the story gets really complicated. We're facing a serious global supply squeeze. This quote from our source material just nails it. The spike in demand, driven mostly by green tech, simply is not being met with enough supply. It's a classic case of supply and demand being out of whack, but this time the consequences are planet-sized. Let's look at a real-world example to see what this looks like. Take India, a huge player in solar. They need somewhere between 5,000 and 7,000 tons of silver every year. But this chart shows you their domestic mines only produce about 700 or 800 tons. That massive gap means they have to import about 85% of their silver, which leaves their green energy plans totally exposed to what's happening in the global market. And here's the real kicker. Mining companies can't just flip a switch and make more silver. A huge chunk of the world's silver isn't mined on its own. It's pulled out of the ground as a byproduct of mining for things like zinc and copper. That means its supply is tied to the demand for those metals, not its own skyrocketing price. And even for the mines that are dedicated to silver, it's not cheap. This table gives you a peek behind the curtain at what it actually costs to run these operations. We're talking tens of dollars per ounce just to get it out of the earth. It really drives home that ramping up production is a super slow, super expensive process. But the solar industry isn't just taking this line down. This incredible price pressure is forcing a massive wave of innovation. The hunt for an alternative is on. So manufacturers are basically fighting back on three fronts. First, something called silver thrifting, basically using smarter printing tech to get the same results with way less silver. Second, they're moving to more advanced cell designs, these new architectures called TOPCon and HJT that squeeze more electricity from every bit of sunlight. And third, the holy grail. They're seriously researching alternatives, with the big one being abundant and much cheaper copper. And they've got to move fast because this financial pressure is not letting up. Just look at these price forecasts for 2026. Even in the most pessimistic scenario, prices stay historically high. The base case, 70 to 80 bucks an ounce. So yeah, innovation isn't a choice anymore. It's about survival. And all of this brings us to a much bigger question, doesn't it? About the unintended consequences of going green. What is the real all-in cost of actually building this sustainable future we all want? Because the ripple effects are huge. High silver costs are putting the brakes on that decades-long trend of cheaper solar panels. It makes massive solar farms more expensive to build, it stretches out how long it takes for developers to make their money back, and it can even put a strain on the government programs designed to help us transition. But here's the fascinating twist in all this. Is it a challenge or is it an opportunity? Because that intense price pressure is also acting like a powerful catalyst. It's forcing the solar industry to get smarter, to innovate faster, and to create the next generation of technology that's more advanced, more efficient, and in the end, maybe even more sustainable. So yeah, the innovation is really promising, but it doesn't erase that fundamental question. As we race to build a clean energy future, we keep finding out that the path is paved with these unexpected costs and really complex trade-offs. It makes you wonder, what other hidden prices are we going to uncover on this journey?